Hey everyone, welcome to the most opinionated space podcast on the internet.
Ad Astra, the podcast where we talk about the intersection between space, policy, and technology.
I'm Jack.
And I'm Newton.
I have a Master's of Public Policy degree with a concentration in Science and Space Policy.
And I'm a PhD in Computer Science and an all-around tech geek.
Okay, guys, don't forget to follow us on Twitter at @AdAstra_podcast, like us on Facebook, and subscribe to our mailing list on elemental.fm to get regular updates from the team. And if you like what you hear, give us a 5-star review on iTunes and recommend us on Overcast. So today we are talking about a plethora of things.
So today, well, let's see what we have here. In our latest from Washington section, we're going to be covering news on Space Corps, NOAA, and the National Space Council. In Space News Highlight of the Week, we'll be talking about the new pick for the Executive Secretary of the National Space Council. In international news, we'll be talking about updates on Luxembourg's role in the space race for mining resources. In our latest in tech section, we'll talk about the latest news in quantum teleportation that's been running around the everyday headlines. And in Coming Soon to Space, we're actually going to give a shout out to a series of local events that are happening in DC. So, latest from Washington. Jack, kick it off.
So we have a lot of stuff happening in Washington. I feel like I say that every week, and like every week it tops the previous week.
There's a lot of stuff happening in Washington.
There's a lot of stuff that happens here, but especially with the budget process hyping up, and with the starting in August, there's always a congressional recess. This is when members of Congress, senators, and in the House of Representatives go back to their districts, talk to their constituents. But with healthcare still not on the legislative calendar yet, and just so many other things happening, there's even a rumor going around that the August recess won't even happen this year. So they're trying to get in. They're trying to get in as much as possible now in order to potentially keep their spring break or their summer break. So the first thing I want to touch on,
please, Congressman,
is that
go home.
Go, and especially the ones that oppose the things that we care about. Go home to your constituents and find out what people really feel like, because you're probably not called enough, so people call your congressman. Anyway, so the first thing I want to touch on is something I talked about a couple weeks ago, was that the current draft legislation, the appropriation legislation for NOAA, or for NASA specifically, we talked about NASA, that it didn't cut Earth science funding in the same way that people are reporting it had. Maybe there's some other conversations happening outside of the official legislation, and that has been the case, with one of the things being NOAA's Polar Follow-On program being cut from NOAA's budget. So NOAA is underneath the Department of Commerce. If you did not know that, it is not its own separate agency like NASA is. It is underneath the Department of Commerce, and they're going to be cutting about $50 million. They wouldn't be cutting $50 million. They would only give $50 million of the $586 million budget for this Polar Follow-On program. So the Joint Polar Satellite System, JPSS, program consists of 2 JPSS polar orbiting satellites that monitor the Earth's polar regions. This is very important for climate science, for remote sensing. It's a very important program. Newton, I'm sure you can attest to the importance of this.
Yeah, not just for climate. I mean, like you said, atmospheric, but you're also talking terrestrial. There's a bunch of land surface measurements that we take off of JPSS, vegetation, rainfall, fire locations. There's a ton of stuff that we do with JPSS. It's one of our most important Earth monitoring systems. So it's interesting. What is their justification for cutting it? And how much did you say they had last year?
So they wanted $586 million for this year.
Well, how much did they get last year?
Program. Last year, I'm not seeing a number. I think it was about 586, give or take maybe $10 million for a program that small. It's not impacted by inflation, of course, by as much. But so JPSS is getting cut down to $50 million. So for context, the Trump administration wanted to give them 180 million, and now Congress is saying let's cut that into a fourth or almost a fourth of what the administration was asking for. So on some fronts, like we talked about a couple of weeks ago, the Congress has been very open to funding climate science programs, to the chagrin of the Trump administration. Now it's the other way around, that the Trump administration wants to fund it at a higher level than Congress. But that's not to say that the Trump administration likes the program. The justification behind it is that it's not, from what it seems, it's not integral to the current abilities of the U.S. government to monitor the Earth and provide atmospheric data, environmental data, because they already have 2 satellites in orbit right now, or at least the program is funding 2 satellites, JPSS-1 and JPSS-2. That extra bit of money would fund JPSS 3 and 4, but with these cuts, it would not be able to fund those, and it would only be able to fund the existing 2 satellites. So it's instead of 4 eyes on the Antarctic and the Arctic, it would be 2. So what is your thoughts on cutting on that rationale maybe?
Now I'm curious, because they stated in this, at least the Space Policy Online article that I'm reading, that they're looking at, while they're seeking cost efficiencies, managing and balancing system technical risks, and leveraging partnerships. But I mean, that seems like a pretty drastic cut, and I'm just curious as to if they were looking at, or if they were at the $580 million range last year, how could they even afford to operate at a $50 million range this year? And I know there. So at the time of this recording,
that's the hope.
Yeah, at the time of this recording, they're still looking to mark up the bill, or still haven't necessarily published the bill. But I mean, that seems like a pretty drastic decrease. Now I know there was a lot of development in JPSS over the last year, just in terms of the monitoring capability, with things like the GOES-R program that's already fully funded. So perhaps that's where a lot of this reduction is coming from, these programs that needed funding last year and are just executing their funding over the next year or two. But that seems like a pretty drastic decrease to me. This isn't one of the areas.
I mean, it is.
Yeah. This isn't one.
But like that's the hope, right? The excuse that they give for cutting this program is looking for efficiencies, managing and balancing systems technical risks, and leveraging partnerships is the most boilerplate excuse for cutting a federal program that I've ever seen. So just for context, I looked up, the Space Foundation has an article, or has more or less a fact sheet on GOES-R, all the other NOAA satellite programs. And so in 2016, the appropriated level for 2016, which was the appropriated level for 2017 as well, with the continuing resolution, it just funded things at the same level as 2016, basically. JPSS in 2016, and therefore 2017, is $808.9 million. The increase to that's decrease to 586 million is sort of in line with the idea that they just launched JPSS 2. They're still figuring out what they need from 3 and 4, and sort of the funding's it goes in ebbs and flows,
right,
in booms and busts.
I mean, what I'm really trying
satellite programs.
What I'm really trying to find out here is, and this may this may be a lot of inside baseball that we just don't have insight into, but how much did this program really need to be cut? Because like you said, they did just launch the second one, and the money that they were looking for seems to have been for the follow-on, which is needed, right? Like, you want to have consistent, constant, multi-instrumented surveillance over polar regions. But it's interesting to what's interesting to me is whether or not this thing has enough funding to execute, to execute its full mission. That seems like, I mean, like I said, the number is fairly drastic. However, given the sequence of events, there was probably a burn down to I'm hoping somewhere near this level, but it doesn't seem wise to me, one, to cut the actual follow on that from something where you've already made that big initial investment into JPSS, JPSS 2, and not go ahead and launch JPSS 3 and 4. And two, I'm hoping that the amount cut will allow them to continue to get the maximum benefit out of the JPSS missions for however long they're intended to fly for.
Yeah, well, if Congress really holds up their end of the bargain and seeks efficiencies, then they're going to fund it at the level that allows them to maximize JPSS 1 and 2. Or this is, again, another incident of politics taking its bite out of science. So that is yet to be seen. We'll be following that one rather closely, I think, because it's such a big program,
right?
Especially in the communities that you and I run in.
Right. I mean, and for context, the follow-on program, it sounds like was only supposed to be funded at $53.7 million. So it looks like that's a chunk of what was getting slashed. However, there seems to be a much larger $500 million hole there. So
yeah, just about $500 million.
Yeah, interesting.
Yeah. So the next thing I wanted to talk about coming from DC is to also answer a listener submitted query. So Newton, if it was your friend who contacted you about this question, so you do the honors of asking it.
So a good colleague of mine heard one of our recent episodes on Mike Rogers and his desire to create a Space Corps, and while some of our reaction was just I think one of the ways that we looked at this was, well, just typical, stereotypical, hyper neoconservative Mike Rogers wants to create another military corps because rah military, which that's a part of his political image that he's trying to uphold. But what my colleague wanted to know was how does that actually benefit him? If the Air Force isn't truly calling for that, and spoilers for a story that we're about to read, the White House isn't actually calling for that, then why is Mike Rogers pushing for this so hard? And Jack, you did a little bit of investigation into this.
Yeah, so this is something that I've had to give a lot of thought about. So I took a course in national security space and have written things about national security space and have been able to follow this paradigm shift that's been happening, both from a historical perspective, looking at the last 60 years of space as another domain in which humans exist, and also as a looking to the future, what obstacles are we going to run into, and what the arguments are going to be on both sides for doing X or doing Y. So to answer the question, why does Mike Rogers want a Space Corps? I mean, part of it I think does boil down to that. His political stance. I mean, he is a hawk. He wants more funding for the Department of Defense. So this whole Space Corps talk began in discussion for the National Defense Appropriations Act, which funds the Department of Defense. It's a massive part of the federal government. It's about 30% of discretionary spending. So why is he's a leader within the subcommittee on defense appropriations, and of course his place as a hawk definitely factors into it. But I think there's also some other things at play here. So you could talk about that in his district. So he represents the 3rd district of Alabama, which represents I think it's a little bit outside of Huntsville. I mean, it's actually a pretty big chunk of the state. It's pretty far outside Huntsville, actually. But Alabama has a history of being a haven for the defense industry. There's a lot of aerospace companies that are based in Alabama. There are a lot of rocket companies, a lot of arms manufacturers. A lot of stuff happens in Alabama. So he has a vested interest with his constituency to advocate for that. Another aspect of it is, so if the first one's constituency, the next one is going to be legacy. So he, of course, wants to leave some sort of legacy. He's like every other congressman. Maybe they want to run for a higher office, maybe not. But what they do want is for their name to be plastered on some building somewhere, or for there to be some hedge fund saved up for their commitment to the cause of building more airplanes that their kids get to go to school forever. Like, whatever it is, whatever their rationale for wanting a legacy is. That's also part of it. And I think the last part is the most nuanced part. And that is that we've been working towards this for a long, long time. So starting back in the 1950s, there was this idea that space is a sanctuary, that space is separate from everything else. That is why the Outer Space Treaty, some people refer to that and the gray areas within the Outer Space Treaty as, maritime law, like it's international waters, that it's not the sole domain of any one nation. That sort of what propagated this idea that space should be a sanctuary, that we should not weaponize space, that there's no need to make space yet another domain for warfare. Now, that's changed over time as people start to realize the impact of space on national security, on the economy, on science, on communication, whatever it is. I mean, space, we rely on space every day of our lives, whether it's calling mom or it's seeing where the bad guys are, whatever it is. So we've slowly been moving away from sanctuary and moving more into a sort of school of survivability, that our assets in space need to be able to survive long term in order to protect our, quote unquote freedoms, our ability to use commerce, to talk to mom, do all those things.
But that's what he's claiming here, though. That he was on NPR the other day quoting that that we have some very aggressive behavior by both the Chinese and Russians in space. Not only in terms of things like things like collection and surveillance, but also just in terms of protecting our space assets. He stated that they have realized that's a great equalizer in terms of sort of the stances on which both of our nations are in, and that they're getting very good at space and fast. I mean, we talked a lot about the Chinese and their space capabilities increasing, and Russia's always been right there along with us, even beating us for most of the initial space race. So, I mean, that seems to be well, at least that's what he's stating is his big motivation. But yeah, as far as concrete things that he's getting out of this, that one's still even up in the air for me. I've poked around and have looked around for this. He's talking about starting a space command in Colorado Springs. So that doesn't really, yes, his district will see some of that funding, given that we know a good chunk of Alabama is focused on rocketry and things like that, but it's still complicated as to why he wants it. I think part of it is legacy, but a good chunk of it might just be I'm not sure who his backers are. Does he have funders that are doing this? Is there a lobbying group that's coming after him?
So there isn't really much in the way of military space lobbyists. I mean, I'm sure he's talking to people in the academic community. So the article that I'm sort of referencing is from this one of my former professors, Peter Hayes, where he talks about the attributes of military space doctrines. And that's where, so that third part, I guess the majority of the reason why he's doing this is not for any financial benefit or for any personal benefit, other than he gets to be the first person talking about this and bringing it up. I mean, this is something that, this article or this book really from Pete Hayes is from 2002, and he's talking about space, command and control. Where Mike Rogers sits, I would say, is somewhere between the control doctrine and the high ground doctrine. I hear him talk a lot about using space as the high ground, that once you have space, if you have control of space, you control the globe, basically. It's the difference between using space for force enhancement and force application. So force enhancement would be communications networks and remote sensing for our troops on the ground. Force application is war fighting in space, or from space to ground, or ground to space. So that's anti-satellite technologies. That's satellite to satellite technologies. That's satellite to ground could be rocks from God, shooting down little bricks of titanium at an enemy. I mean, there's so many different ways, kinetic, energy, laser, all of these different avenues you can go down, and the rabbit hole is endless of what technologies can be developed from a high ground or control perspective. But the first step to all of those things is this unified command, such as a space comm or a space corps, leading into a space force. This has been something that's been talked about since, I think, the first iteration of Space Force was in 1962, I want to say. I can't remember the author or anything, but it's the idea that just as the Air Force was created out of this new domain of the air that really didn't exist 40 years prior, that soon we're going to need force in space, that we're going to need, whether it's some sort of manned fighter jet in space, or if it's satellite to satellite combat, there's going to be war fighting in space. It follows this idea that there's a trajectory to war fighting domains, same as with cyber and with air, is that over time it's going to develop to the point where people are going to weaponize it anyway. And as he mentions about China and Russia, that they already have weaponized space and used weapons in space to varying degrees between the two of them. I think he points specifically to the 2007 ASAT test that China did that created about 25% more space debris. So that's where I think he's coming from, is that he wants to be the first one talking about this, and the first one to propose this amendment, so that it's the new Space Corps headquarters in Colorado Springs is named the Representative Mike Rogers Space Corps headquarters, or whatever it is. So that's where the legacy, I think, comes into play. So I think that's where he's coming from, but no one seems to agree with him. Like we talked about the last couple of weeks, is other members of Congress don't agree, and the academics in military space don't agree. And now...
Can I say who might agree, though?
Who?
Real quick. GenCorp Inc., Lockheed Martin, Honeywell International, Defense Aerospace, Defense Electronics, miscellaneous defense companies, who are his top 5 campaign contributors. Or, I'm sorry, top 10 campaign contributors.
So you did some good research. Yeah, I mean, they absolutely have a say in this, because they directly benefit. I mean,
these were the PACs these were the main PACs for his 2016 campaign, and it looks like they're going to be for the 2018 campaign. So
yeah. So he has this financial benefit that he gets from it. He probably meets with these people at least once a week. But the thing is that, yeah, academia doesn't agree. A lot of Congress doesn't agree. That provision of the bill didn't even make it in to the NDAA. So it's almost a moot point talking about it. But it's important to note that the White House thought it was so controversial that they had to make a statement on it. And in their sort of review, their statement of policy. The White House does this from time to time, where they release a statement, requesting changes or making note of things that they like or don't like in a bill that's in the Congress right now for the National Defense Authorization Act. They mention specifically the Space Corps. The statement says, quote, "The administration appreciates the committee's concern with the organization and management of DoD's space capabilities. The administration is assessing a wide range of organizational options, including a Space Corps. The creation of a separate Space Corps, however, is premature at this time." So the exact same argument I've been putting out, the exact same argument that academia and other members of Congress have been putting out, Mike Rogers seems to be alone in this sentiment. But it is important to note that they
with Lockheed Martin, Honeywell.
Yeah, alone with a couple $billion.
Defense aerospace.
Which, are you really alone then?
Yes.
But so what's maybe more important to note than just the White House is agreeing with literally everybody else and saying that Mike Rogers' proposition is not good for now is that they are looking at this option. And it wouldn't surprise me if this was something that came up in a couple years as well, as the National Space Council, I'm assuming, is going to last for the entire administration, if not longer than that, that they start looking at these priorities for the administration being defense, being national security. Half of the National Space Council comes from a defense or intelligence side of the government. So they obviously care about this stuff. And so I wouldn't be surprised if we saw this again come authorization and appropriation next year as well, which sort of leads into the next article that we'll be talking about. I hope that answers the question, why does Mike Rogers care about a Space Corps? But so the White House and the Congress, specifically Brian Babin from Texas, wants the National Space Council to address Air Force problems with space and the role that the Air Force is supposed to be playing. So some of the things that they want them to focus on is space technology acquisition, talking about how does the Department of Defense, specifically the Air Force, get access to technologies that are being developed by the private sector or putting out an RFP for new technologies. They want to tackle space junk. They want to tackle all of these very minute problems, these problems that are very in the weeds and not very sexy problems.
Well, go on. Sorry. Go ahead.
And I think my immediate reaction to this is, although as the Office of Management and Budget Director Mick Mulvaney said that the revival of the National Space Council is going to have a de minimis impact on costs and revenue of the federal government, meaning it's not going to cost us anything more and it's not going to get us anything more, that the benefits will allow us to, or the benefits of NSpC is going to be that it's going to allow us to implement new policies, create better strategic planning for space assets, figure out these long-term problems within NASA and DoD. Although the administration supports all of it doing all of this, my immediate reaction is the administration probably does not want NSpC to be dealing with space trash. They want it to be this big, we're getting humans to Mars by 2024 or whatever it is that they really want. But I think you have some good thoughts on this as well.
Well, my concern is like I've stated in previous episodes, is sort of the level of the level, the added layer on top of the current space infrastructures of Air Force, NASA, NOAA, and the insight that effectively the White House is getting into these different agencies. There are already agencies that are attempting to address the space junk problem, and I'm sure they are happy to have a space council, strictly because they can highlight the issues that they've been having. a bit more, but just the way that this news sometimes comes off or is reported is as if they are going to have this high level view and create these nuanced solutions to problems that each of these agencies have been trying to address for the last several years. Once again, the Space Council will be beneficial in each of these agencies being able to highlight their problems to the council. My big concern is the members of the council not having as much insight into those agencies and how those agencies work, and potentially adding layers of red tape. But that's a fear, not really grounded in any data, because we haven't seen them operate or interact.
The first meeting isn't until later this summer, at the end of August, I think. That, like, I think you're right that it has the potential to be very helpful in allowing DoD to air their grievances about the way their acquisition system works, or for NOAA to come in and say, hey, we're having these problems with satellites. Hey, NASA, you're really good at satellites. Help us. That's going to be great.
The concern is that seems like that could have happened anyway. Do you see what I'm saying? Like, yeah. That could have happened without this layer. But it
could have happened without this layer, but this gives it that space to do it. Mm-hmm. And by putting the vice president in charge, it elevates the status of these issues. So the administration is going to say, hey, the NOAA guy made a really good point. Let's get something through Congress or work on an executive order if that's going to help. Like, it'll be helpful in elevating the status of these issues, but the problem you run into there is that space is so diverse because it touches so many parts of everyday American life that an NSpC meeting could last easily a couple weeks straight if they wanted to hear everybody's talking points.
And once again, that has its benefits and detriments. You will reveal problems. It could
bog them down because they can't create national policy every time they have a meeting, which is probably what some sectors of the government's going to want, is like every time the National Space Council meets, they're going to want an executive order, 2 pieces of legislation, and a speech from the president. That's not going to happen.
Right. I would advise the National Space Council with my, I would suggest proceeding with caution when addressing issues that, and you also run into the issue that that some agencies also have. Every agency believes that their individual issues need to be highlighted above others, and you're going to run into some issues with sort of prioritizing what you address and what you don't address as well.
Wait, there's infighting in the space community?
I know, what? Crazy, right? Never happened. By the way, I think we should go to the moon. Why are we at the moon right now? No, I'm just kidding.
Well, speaking of the moon, our space news highlight of the week, my former professor and a very good friend of mine, Scott Pace, got picked to be the executive secretary of the National Space Council.
What?
Yeah. So in my last semester of my master's program, I took a course with Dr. Scott Pace, which is, side note, it is hilarious that his name is Scott Pace because the way GW does emails, it's first initial last name. So his email is just space.
He was made for this job.
He was absolutely made for this job. Also, if you're listening and try to email him, like, it probably not going to go through because he's already over at the White House now.
Anyway, he probably has it forwarded, just like everyone else.
But anyway, so everyone seems to be ecstatic, or at least in my circles, ecstatic that Pace was picked. He was, among us wonkier types, the pick that people wanted for administrator of NASA. But this is, I would say this is a better job for him. So knowing Dr. Pace, he doesn't like the limelight as much as some people do, Trump, but he loves being in the back room, making the deals, gathering information between stakeholders, formulating committee meetings. He loves doing this stuff. So he is very well suited for this job. And so congratulations to Dr. Pace. But the big thing that I think to get out of this is with them picking Scott Pace for this position of executive secretary, a position that more or less drives the National Space Council's agenda, we might start seeing a pushback on current NASA programs. So of course the National Space Council is not just NASA, it's 13 other groups. I think in total there's 8 different agencies or major parts of the federal government that are represented, from commerce to transportation, NASA to Department of Defense. The thing about Scott is that he loves the moon. So for when it comes to civil space policy, the last, I'd say 8+ years, I mean, even going back into the Bush administration. So the last close to 20 years, we've been focused so heavily on getting to Mars and sort of brushing aside this moon question that I think we're going to get the moon answer. And many of us in the community might not like it, but that's just sort of who Dr. Pace is.
I mean, are you thinking about a fundamental change in missions, or using the moon as infrastructure? You think a fundamental change in missions is going to come out of him?
Yeah. Well, so some of the things that he highlights in congressional testimony, talking to him in class, in seminars that he's given, is that he was very critical of the Obama administration and very critical of the sort of piecemeal program, as he calls it, that was put together for getting to Mars. That it took kind of bits of Constellation, took parts of Space Shuttle, took parts of ISS, kind of put them in this weird order that didn't make much sense at the time, and it
seemed non-committal.
It's non-committal. Yeah, you're right. That we're not. I mean, like for maybe comparison's sake, for Apollo, it's not like, on May 25th, 1961, Kennedy said, "Oh, we're going to go to the moon on July 24th, 1969." It's not like that happened. That there was also that sort of non-committal aspect to the Apollo program.
Lot less than Obama, though.
But the destination was there.
Yeah.
Like with under Kennedy, Johnson, and Nixon, it was like the moon is the destination. There is no way anything is going to make us stray from that. For the current Mars program, I mean, it's not even called the Mars program.
Right.
First off, and it's just so. Maybe we'll go to an asteroid. Maybe we'll just go to the Deep Space Gateway. Maybe we'll go to the moon. Maybe we'll go to Mars orbit. And everyone has their opinion, and everyone's opinion is different. There are people that I know who are super into, Mars orbit first and then land. I know there are people that are super into not a lot of people are super into asteroids, but there's a couple that are. Scott is one of the moon people. I would not call him a lunatic. Although I disagree with him on a lot of his views, both in space and otherwise. He is a very smart guy, smarter than I ever imagined I could ever be. And him leading this is going to adds a lot more credibility to the organization that is the National Space Council. I think what we need to start bracing ourselves for as Mars fanatics, Mars heads, I don't know if we don't have a cool name like lunatic, is that 2033 might not be the year. And that might be something we have to accept. I mean, you can make as many arguments as you want about Elon getting there first, but if there's no government funding, which is over half of Elon's SpaceX's budget every year, or their revenue every year, if there's no government funding for getting things to Mars, then their program is going to falter.
So I think what might be getting underestimated here, though, is the interaction with the current administration, because I feel like the current administration is all about deep space, well, deep space and extra lunar exploration. So, how do you think he's going to interact in that space?
So I wouldn't say that the administration has been extremely involved in deep space exploration, that
but they're extremely interested in it. They are certainly not enemies of it.
Yes, they are interested in it, but from a more political stance.
Yeah.
That this is something that has
grandeur.
A lot of, well, yeah, it has that grandeur aspect to it. It has that potential for being legacy building, going back to what we were talking about with Mike Rogers. But I don't think the administration, not just this one, but previous ones, have been married to the idea of Mars. It's just Mars makes the most sense because we've already done the moon. But as Scott has told us numerous times in class, and has probably said on Capitol Hill a number of times too, yeah, our grandparents went to the moon. We didn't. So his approach is going to be to organize the National Space Council in a way that when they're pushing forward, implementing this civil space policy, or not even implementing, but creating it, it's going to be very moon-centric. It's going to be very lunar-centric. So I've already started to prepare myself for the idea that maybe 2029 or something is going to be a great year for space, because we're going to have humans back on the moon with the American flag on their armband. But I'm increasingly pessimistic about Mars in 2033. Now, if there is a major funding boost to NASA, if it's suddenly they're going to double the NASA budget, and then suddenly there's this major outpouring of support for NASA and getting humans to Mars, even more so than the Apollo days, getting humans to the moon, then I could see it. But otherwise, I think moon's the next destination.
Okay, well, to the moon.
To the
it's better. I guess it's better than nothing. Add Luna.
You don't sound very convinced. We'll have to get Scott on the podcast.
We'll talk. I'll talk
have him
Scott.
Convince us.
So moving on. You got anything else in Space News Highlight?
Nope. That's it. Other than, congrats to Scott.
Congratulations, sir.
Like I said, even though I disagree with him on some things, I'm glad to see someone competent at the helm of the National Space Council.
Right. So moving on to international news. So on July 13th, the government of Luxembourg passed a bill giving companies the rights to space resources that they extract from asteroids or other celestial bodies. Luxembourg's Chamber of Deputies, which I didn't know that was called that, voted 55-2 in favor of the Space Resources Law on July 13th. The passage of the bill means the act will become law on August 1st. Luxembourg is actually going to be the first adopter in Europe of a legal and regulatory framework recognizing that space resources are capable of being owned by private companies. So the Outer Space Treaty, it doesn't allow you to actually own the actual celestial body. However, what this legislation, as well as U.S. law, states is that you are able to, once you have extracted resources from a celestial body, if you are the individual to extract it, you own it. The government of Luxembourg stated that they're to promote international cooperation in order to progress on a future governance scheme and a global regulatory framework of space resources utilization. This is sort of a path that Luxembourg, this very, very tiny country in Europe, has been following even up to last year. We remember hearing news about a 200 million euro fund that they created to entice companies that were focused on mining asteroids to relocate themselves there. Back then, Luxembourg's economic minister was quoted as saying the fund's budget could expand if needed, and that it is aimed at making the country, which is about the size of the Dallas metro area, a global leader in space. So it looks like Luxembourg is getting ready to have its own space economy, one that's very different from the one we're generating here in America and in other private places like New Zealand or in parts of South America. So, Jack, we've talked in the past about the Outer Space Treaty. How do you think that this would play into at all any revisions to the treaty that are certainly going to get made because Ted Cruz is the most favored congressman or senator in all of Congress?
Well, yeah, anything Ted Cruz wants, he gets. So what this is going to do is it's going to elevate the issue. I think we say that about everything when something happens in space, but with another country adopting similar legislation to what the U.S. adopted in 2015, that is going to make this an international issue. So it's no longer just the U.S. that the Committee on the Peaceful Uses of Outer Space, COPUOS, will be reprimanding. It's going to be Luxembourg too. So the U.S. is no longer alone in getting reprimanded by the UN. But I don't think that Luxembourg's the tipping point. I don't think we're going to hit a tipping point until maybe even after the Lunar X Prize, if it's won, happens. Or if, say, SpaceX launches something in the next 2 years that picks a rock up from the moon and brings it back, or grabs a nearby asteroid and brings it back to the ISS or something. Whatever the possibility is, if it happens, that's when we're going to start hitting that tipping point for whether Outer Space Treaty is outdated, which it is. But I don't think before then are we going to start really talking about this, because it's so theoretical. The Outer Space Treaty was written in a time, 1967, when they thought in 30 years you'd have 1,000-person space stations and people on every celestial body in the inner the rocky planets. That's no longer the case. That we, one, think that, and two, that hasn't happened yet.
Or that it's even a public desire.
Or that there's even that public desire. Yeah, there's all the cultural artifacts like The Martian and Interstellar that talk about humans exploring the solar system and going out into deep space. But until it's actually realized that there is something like this happening, where companies go up and bring rocks back from the moon, we're not going to see much headway on this. But what Luxembourg's trying to do is push that envelope a little bit further and invite commercial companies to their borders. I mean, Luxembourg's a small country. Like you said, it's only as big as like the Dallas metropolitan area. But I mean, skyscrapers go up. There's a third plane of buildings, so there's room to grow in Luxembourg, especially in the urban centers, in places where they want to bring high-tech jobs and industries that maybe don't rely on actual manufacturing, but on the creation of ideas and the incubating of grand ventures like this, like bringing resources back. I mean, there's trillions of dollars of resources in the solar system. If we're going to ever tap into these types of situations need to start happening earlier rather than later, so that future comes a little bit closer.
Well, and I was going to say too, like Luxembourg, it is, because of how tiny it is. I mean, this economy, that what they're trying to do could potentially spread out to some of its neighbors. I don't think it's going to become Belgium, France's, or Germany's main industry. I think, well, quite frankly, I think a good chunk of their industries are going to be, as far as space is concerned, is going to be focused potentially on Earth sciences and Earth monitoring, given where they're going with the Paris Agreement and all of that. But I do think that this has, because Europe is so small, because Luxembourg is so small, that this is a great way of sort of seeding this notion of mining asteroids and mining other planetary resources in Europe, and just sort of having that grow and spread out across.
Yeah, I kind of wonder if the Founder Institute, that group that we talked about that was a couple months ago.
Oh yeah, does this count as a?
Yeah, does this count as a space startup? The entire nation of Luxembourg.
I
wonder if
it's
there's
the size of a company.
conversation.
So like, I'm just kidding. I love Luxembourg. I was there like 5 years ago. I think it was a beautiful place.
Yeah, I've never been. I guess I'll have to go to see their blossoming space industry.
They have some really cool castles. Really great place for launching rockets. Like they make great decor.
You just have a Falcon 9 right next to some castle from the early 800s or something.
Right. Luxembourg is pushing forward with this thing. This is a way for them, like I said, to build this part of their economy. They are already a very, very rich nation, and it'll be interesting to see where they go going forward. I mean, Europe really should be leading this sort of chunk of the space race. I mean, we all remember Philae about 3 years ago, back in 2014, which was the lander for Rosetta that landed on Comet 67P. I think it was named Churyumov Gerasimenko. And they were the first ever to have an actual lander land on a comet. So that was European Space Agency. That was ESA, and I'm hoping that they can sort of take the reins when it comes to going to these extraterrestrial bodies and mining for resources. This needs to be a field of the future.
Absolutely.
There are precious metals, there are precious resources that are just lying, that are very rare here on Earth, or at least rare in the sense that we have significant trouble accessing them. Where, it's interesting to think about it, but it could potentially become easier accessing them from space in the future, not now, obviously. So we'll see where this goes. Anyway, moving on to latest in tech. So
I've seen this article posted everywhere about,
literally everywhere,
about them being able to teleport something in space.
So something is a very interesting way of putting it. so just to be clear, you guys haven't been fooled. Teleportation is actually a real thing, and it's just not at the level that we want it to be. So
was it like a jacket or a marble or
no
a can of beer that they teleported, or
it's something even more valuable, which is information. I just kind of want that rainbow. The more you know. So the Chinese have just set a record for teleportation to a satellite in orbit 870 miles above the Earth's surface. That's about 1,400 kilometers. And to tell you how they did it, first we're going to have to talk a little bit about teleportation. Okay? So strap in. First of all, folks have teleported things like photons, neutrinos, electrons, molecules the size of buckyballs before. This is not necessarily a new phenomenon. We've even apparently teleported small diamonds. And to understand how we did that, first you have to understand a phenomena called quantum entanglement. And I promise this won't be a detailed lecture, and there's no quiz afterwards.
I'm relieved at that.
Yeah. So quantum entanglement, the best way I can describe this, it's the transmission mechanism that makes quantum teleportation possible. Saying two particles are entangled is just a way of saying that they have physical properties that can be appropriately correlated. So you're talking about things like the spin of an electron correlating to the spin of another electron, that it theoretically could be correlated to the spin of an electron halfway across the universe, or something, or things about something's quantum structure, its quantum location. We found when analyzing particles in the quantum space that two individual particles halfway across the universe can be correlated. And this really is more about transfer of information than transport of any physical thing. In fact, there's an entire field of information theory called quantum information theory that's about observing, manipulating, and passing information through quantum entangled photons. It's also used in some protocols of quantum cryptography, where the entanglement permits what's called a one-time pad, which I won't get super into because I'm a big crypto nerd, but a one-time pad is just a key.
Obviously,
it's just a key that's used only once, so that it can be, so that it can't be easily figured out. But the speed at which this information can be passed on instantaneously is where quantum teleportation really comes in. So we have the fact that two particles are somehow correlated. If I move this one, this other one can move. If this particle has a spin at this angle, this other particle at the other end of the at the other end of the galaxy has a spin at this at this angle, right? Or at least as far as we've measured, this particle at this end of this lab and this end of at this end of the other lab. So, as I said before, the reason we have to talk about quantum entanglement is that since entanglement can be maintained over arbitrarily long distances, entangled particles are the transmission mechanism for teleportation. You send a pair of entangled objects to two separate locations, and one of them acts as sort of a mold or a scanner and imprints the thing that we want to teleport. And the other object, because it's entangled with the first object, becomes a sort of negative, like a photo negative of the object on the other side, because you're just forcing sort of the operations that allow for the transfer of that information. In other words, quantum teleportation instantly transfers the condition or state of one quantum particle to another distant one without sending the actual particle itself. And there's been a ton of research about this over the years. As far as quantum crypto goes, that's concerned with doing this over the internet. We found a host of different information passing mechanisms just using photons. But in their latest experiment, this Chinese team, led by Zhigang Ren at the University of Science and Technology, fired a laser from a ground station in Tibet to a satellite in orbit. That laser beam carried a photon entangled with another photon on the ground. They then entangled the photon on the ground with a third photon and measured their quantum states. But the scientists didn't actually reveal the states themselves in this experiment. They just asked whether their states were the same or different. So they just assessed whether or not when they changed one thing, they could perceive a change in another thing, which the article that we'll post on spacenews.com makes it seem sort of, it makes it seem like it wasn't that that great of achievement because they only observed whether or not something changed. But I mean, this is very big news to be able to reliably change the state of one object 870 miles away from another object really does permit or at least demonstrate that the phenomena can be exercised over very long distances. And it's quite difficult because it is such a rapidly moving target, especially when you're talking about a satellite up in space, and you have your quantum detectors way out in space, and they have to actually work without anyone actually messing with them. This is sort of the first exercise and demonstration of a potential for global scale quantum communication. And this is, like I said, this is something that's been tried before in basic labs around the world, where we could see a particle changing about 50 miles from another particle, but that doesn't give you a quantum internet. Demonstrating that it can happen 870 miles away is extremely powerful. It's very hard to measure and make entangled pairs do exactly what you want them to do, and to some extent, this Chinese this Chinese lab has demonstrated that. This has the potential to be used significantly in the future for secure space-based communication and things like actual fast satellite internet. I mean, satellite internet is extremely slow. We actually have the potential to be able to use this for things like satellite phone service, which is not prevalent at all. For just fun fact,
we had basically an entire economic crash around that in the late 90s.
Right. I mean, your phone, and not a lot of people realize this, your phone doesn't interact with satellites for the most part. Like, most of your phones don't interact with satellites. They interact with terrestrial ground stations, like just stations sitting here on the ground, and you just walk back and forth from station to station. And we've had to build a ton of these, but this actually makes it feasible for us to not have to do that anymore and just use satellites for communication. And effectively, what would happen is that information would be passed back and forth between your phone and your phone, entangled set of photons on your phone, and that are entangled with a set of photons on a potential satellite, and or some other relay mechanism, and that would allow for you to actually quickly communicate with someone else on the other side of the Earth, which is in a very feasible way, as opposed to what satellite communication would be now, which is just having a very strong antenna, a very powerful antenna, but still having a significant delay. So it's an interesting field.
Well, and then also think about the applications for maybe a more immediate application would be a mission to Mars, right? Like,
absolutely.
If you're able to, that could be a proving ground. I mean, I know we just finished talking about how we're not going to Mars anymore, but we very well could be. You never know.
I'll fight to the
death. We'll fight for Mars, but that could be a proving ground, or even if it was just with rovers on the surface, or a new satellite going out to Pluto,
right,
that we could be able to communicate with them in real time, as opposed to dealing with that 43-minute time delay. I mean, it could eliminate some of the biggest problems facing human exploration of the solar system, which is access to home. And it could completely bridge that gap.
It's interesting that Einstein is one of the first to have discovered this, and then his theories led to a speed limit on the universe, effectively, right? The speed of light. And this form of communication is how you bypass that. This, because you can observe, you can have the object on the other side of the solar system observe the change instantaneously. As your particle changes instantaneously, the other particle changes.
And this is like real instantaneous,
right?
Not
right.
There's a delay or latency.
Right.
It is.
This isn't.
If
this
it
isn't
happens
us.
to you, it happens there at the exact same time. But then you get into the weird discussion of what time means on the grand scale.
Time
of
only
space,
matters because of matter, and that's a much longer conversation. But yeah, you're able to have communication across there's no more 7-minute or in many cases what will be an hour delay for Mars, right? There's no more several or 8-hour delay for Juno or for any of the extra Jovian planets, right? Now you can have instantaneous communication, which It's amazing that these guys were able to do this. The other big one, and I am going to nerd out a little bit about this, is cryptography. All right, the power of having,
oh, you and your cryptography.
Yes, the power of having a one-time pad is, I mean, that is incredible for the security of communications on just human based internet, right? Cryptography, or rather breaking cryptography, is a game of finding the keys. And you want to take a key that people are using to transmit information and make it such that you can't steal that key while people are transmitting that information. Often when you're communicating on the internet, as we're communicating on the internet right now, we're using a key to secure our communications. And for a period of time, we'll be using the same key. If somebody were to capture that key right at the beginning of our communication, they would be able to observe, they would be able to decrypt the rest of our communications. Quantum teleportation allows that to not occur anymore, because now you can continuously continuously agree to a new key between both parties that are communicating. So right now, the big holdup for us using a one-time pad is that we always have to go through this key distribution process. But if I had quantum entanglement, you'd have some form of a quantum detector with a set of particles that are entangled with a set of particles that I have, and we would just distribute a key instantaneously, and we would do that for every bit of communication that we would have. And we would be able to do this extremely fast. So you're talking about super fast, secure communication. I mean, that's invaluable. So that's why I can see a lot of investment on this, both on the NASA side as well as on the military side. This looks to be really interesting, and I'm interested in seeing where folks take this. Once again, it has to become more reliable. We have to do more than just observe a change. But it's good to see the research being carried forward, I think, and I'm pretty sure that both NASA and the military are investing in this same kind of research, as well as NSF and NIST. And I hope we can also leverage this technology in the future. So,
well, all right. Quantum entanglements, space, technology, policy. Oh my God, we covered everything.
We covered literally everything. So just a few quick announcements for coming soon to space. The Capital, if you're in the DC area, the Capital Riverfront Outdoor Movie Series is going on over by the Navy Yard area. On July 20th, they will be playing Rogue One, A Star Wars Story. So that's a day after this episode airs. They're going to be playing it by the Capital Riverfront beginning at sundown. So you can join them as early as 7 o'clock p.m. The other major event that's going on is on August 1st. So that's in about 2 weeks. Astronomy on Tap, a local DC group, will be hosting another event at DC9 Nightclub. Now, if you haven't been to an Astronomy on Tap event, you have to go.
What's wrong with you?
Yeah, what's wrong with you? You get to drink and hear people talk space and talk space yourself, and do some space trivia and win prizes.
Talk space. Did you say that?
And talk space. I said that. They're going to have a number of guests. They're going to be talking about the solar eclipse and Cassini's grand finale, and what we've learned from sending rovers to Mars. So look out for that. It's going to be once again at the DC9 Nightclub here in Washington, D.C. These folks are partnered with the Public Observatory at the National Air and Space Museum to set up a telescope for viewing on the rooftop of the bar, weather permitting, as always. So there's your local DC events that are coming soon. Sorry to our listeners in other places.
When we grow to the size of Star Talk, we'll be able to have specific podcast for certain areas, right?
Right. Well, we'll have specific announcements for certain areas. We'll hire interns. It'll be a whole.
We'll do a whole thing.
Yeah.
But so a couple
All
other
right.
things. The ISS R&D, the International Space Station Research and Development Conference, being put on by the I think AAS, the American Astronautical Society, is having their conference this week. By the time this airs, the conference is basically going to be over. It's from Monday until Thursday. The keynote speakers are Elon Musk, who I think everyone on this podcast knows, Kate Rubins, who is a former NASA astronaut who is up on the ISS in 2016. Some of her research has been in microbiome experiments and heart cells, the creation, the I guess, propagation of heart cells in a cell culture, and Robert Bigelow, the founder, president, and program manager for Bigelow Aerospace. So be sure to tune in if you're able to for those. If not, I'm sure it's going to be on YouTube. Another cool announcement that I found, Buzz Aldrin gave out the first annual Buzz Aldrin Space Innovation Award to, drumroll, Jeff Bezos, not Elon Musk. But so that's interesting. Go ahead, head on over to Buzz's Facebook, and you'll see the photo from the event. Another awesome thing that happened is that our producer, Tom Kelly, is now engaged.
Congrats, sir.
Congrats. So everyone
And
who is
congrats,
listening, be sure to tweet at Tom Kelly. It is at TKells, TKELLZZZ. ZZZ, however you say it. Tweet at him and tell him congrats. And that is, I think,
That does
everything that we have. Except I did want to bring up one last thing. I know we're over an hour and 10 minutes now, but currently Saturn is winning the favorite planet contest.
As it should.
I know
I've
we
made
both
up my
voted.
mind over the last week.
Yeah, we both voted for Saturn.
Yeah.
Just full disclosure, but Saturn has 51 votes. Mars is now in second place with 36. Jupiter with 33. The ice giants sit with 31. Mercury with 9, and Venus, poor Venus, has 4. You can comment on any of the posts that I made on Facebook, and say Pluto, and it will also count as a vote for Pluto, even though Pluto can't win this contest because it's not a planet. Stop telling me that it is, because it's not. But Pluto's at 15 votes. So let's go Saturn, or whatever your favorite planet is.
Well, I think really what this means is we're gonna have to eventually get Carolyn Porco on the show, because I mean she's Miss Saturn. Like we just have to at this point.
Absolutely.
Yeah.
I think we have a bunch of we know a bunch of people that love Saturn. That's just the people that we run with. So
Yeah. So
Saturn for life.
Yep. So
yeah, as always, I'm Jack.
and I'm Newton
Ad Astra.